In this video, I'm going to work some practice problems converting binary to decimal numbers. Okay. Step 1 is to write out the powers of 2. Because if you remember, all binary is, or to convert from binary to decimal, all you have to do is consider the 1 and the 0 in its position multiplied by a power of 2. So first, 2 raised to the power of 0 equals 1. Don't forget that. A lot of students will make mistakes getting confused with that exponent. 2, any number raised to the power of 0 equals 1. 2 raised to the power of 1 equals 2. Any number raised to the power of 1 is itself. From there, all we're actually doing is doubling the number. So 2 raised to the power of 2 equals 2 doubled, which is 4. 2 raised to the power of 3 equals 4 doubled, which is 8. So on and so forth. So I'm just gonna kind of use a shortcut here. And I'm going to back up and I'm just going to write the powers of 2 across the top of the page. 1, 2, 4, 8, 16, 32, 64, 128, 256. Okay, I'll stop there for right now. So let's create a number, a binary number to convert. Instead of looking at the chart, I'm just going to pull one off the top of my head here. And I'm going to write things in bytes, which means I'm going to always have 8 zeros and ones. So I'm going to do 4 zeros. Let's see, 1, 2, 3, 4. And I'm just going to 1, 1, 0, 1. There. All right. So if you'll remember, you actually ignore any position that has a 0 in it. Because 0 times any number is 0. So we don't have to worry about those. And for the positions that have 1s, we just record the power of 2 in that position. So let's look all the way to the right. This is the 0 position. 2 raised to the power of 0 is 1. So I'm going to put a 1 down. Plus, okay, I'm going to go one position over to the 1. So 0, 1. 1 has a 0, so I'm going to ignore that. Then I'm going to go to the next position, so 0, 1, and 2. 2 raised to the power of 2 is 4. 0, 1, 2. In fact, you know what? Let's make this even easier. I'm going to write across the top the power that I'm considering. 2, 3, 4, 5, 6, 7, and 8. Okay? So, let me see, where was I? 0, 1, 2, 3. 2 raised to the power of 3 is 8. So I'm just going to add an 8 here. Okay? So that gives us 1 plus 4 is 5, plus 8 is 13. So, 0, 0, 0, 0, 1, 1, 0, 1 equals 13, or is the same thing, I should say, as the decimal number 13. All right? Let's do another. Let's see, let's do a bigger number this time. So I'm going to do 0, 101, 1, 1, 0, 0. And let me see, was that 8? 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros and 1s, so that's another byte. So what number does this one represent? Okay, well, the 0 position is 0. The 1 position is 0. 0, 1, the 2 position has a 1 in it. Okay, so 2, the power of 2 for 2 is 4. 4 plus, okay, go one more over. Have another 1. So the next, the 2 to the 3, 0, 1, 2, 3. So 2 to the 3 is 8. Okay. So then 0, 1, 2, 3, 4 at the fourth position. I have a 1, 2 to the 4, 16. And let's see. So then we've got a 0, 1, 2, 3, 4, 5. The sixth position has a 1. So that's a 64. All right. So then all I've got to do is add those numbers together. 16 plus 64 would be 80, plus 8 would be 88, plus 4 would be 92. So 0, 1, 0, 1, 1, 1, 0, 0 equals 92. I wonder, what's the largest number we can represent with 8 zeros and 1s? In other words, what would be 1, 1, 1, 1, 1, 1, 1, 1? Because if we're going to go any higher than that number, 1, 1, 1, 1, 1, 1, 1, 1, then we would have to add another position, correct? Okay, so how would we calculate the largest number we can represent by 1, 1, 1, 1, 1, 1, 1, 1? Okay, that would just be all the powers of 2 in all the possible positions added together. So position 0, position 1, position 2, position 3, position 4, position 5, position 6, and position 7. All right, so that would be 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. Now, I could add all these numbers together, or I could think about this just a second. 1, 1, 1, 1, 1, 1, 1, 1. What would be the next number in binary that would follow this number? What would be this number plus 1? Well, that would be 1 followed by 8 zeros. Because we can't go any higher with 1s here. So what would you do to make a number larger than 1, 1, 1, 1, 1, 1, 1, 1? You would have to add a position to the left. Okay? So what would this number be? Well, all these are zeros, so I can actually ignore them. So 0, position 1, position 2, position 3, position 4, position 5, position 6, position 7, and then position 8. Okay, looking at my chart here, 2 to the 8 is what? It's actually 256. So 1, 0, 0, 0, 0, 0, 0, 0, 0 is in decimal 256. So what would 1, 1, 1, 1, 1, 1, 1, 1 be? What would this number be? It would be 1 less than 256, which in decimal would be 255. So, the largest number that I can represent with 8 1s, or with 8 zeros and 1s, is going to be 255. We could easily verify this by adding together 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. And you'll see the answer will be 255. Let's work a few more before calling it quits. Okay, so this time let's, I don't know, we'll do another small number again, so I'll put 4 zeros. Spread these out a little bit this time, maybe that'll make it easier to see, and then I'll pick a number. Tell you what, let's make it really easy. I'll just put a single 1 in there. Okay, so this time we really don't have to do too much thinking. 2 raised to the 0, we have 2 zeros here. We only have 1 1 in the entire number. So all we have to do is figure out what that position is, which is 0, 1, and 2, and then look at that power of 2. 2 raised to the power of 2 is 4. So this number in decimal is 4. Okay. Oh, we'll try a hard one. 1, 1, 1, 1, 0, 1, 0. Oops, missed a number. We'll add another 0 there. Let's see, I'll add some spaces here. Okay. So you should be getting the hang of this by now. All we have to do is look at the ones and see what the matching number is in the power of 2. So 0, 1, and 2. 2 raised to the power of 2 is 4. So 4 plus, okay, 0, 1, 2, 3. And then we have 4, 5, 6, and 7 as all ones. So 4, 2 raised to the power of 4 is 16. 2 raised to the power of 5 is 32. 2 raised to the power of 6 is 64. Oops, how did that equal sign get there? And then 2 raised to the power of 7 is 128. 64 plus 128 would be 192. Let me rewrite this. It's getting a bit large. So 4 plus 16 plus 32 plus 192. Okay. 192 plus 32 is going to be 224. So let's rewrite it again. 16 plus 224. Okay, 224 plus 16 is going to be, let's see, 40. And then plus 4 would be 44. So we'll just skip ahead. And 11110100 in decimal, in base 10, can be represented with the two symbols 4 and 4, 44. Okay, so I believe you should have the hang of it by now, I hope. You write out step 1, you write out the powers of 2 so that you can easily calculate the positions. Then you figure out which positions in the binary number have a 1, and then you add those powers of 2 together. Easy, easy. I'll include a discussion on binary to decimal, or decimal to binary to decimal translations, and if you have one that you're having trouble figuring out how to work, post in that discussion, and then either a fellow student or myself will work that out for you. Thank you.